Welcome back to Reflections. And the first one we're going to talk about is when a function is reflected across the x-axis. To do that, we multiply a negative on the outside of the function. So I'm going to have minus f of x. The graph actually flips or reflects across the x-axis. So looking at my example, it says to graph the parent function f of x equals the square root of x. And if I remember correctly, I'm hoping I do, we start at the origin, and that is the square root, the graph of the square root of x. It starts at the origin, does not go negative. Now, looking at the next function, g of x, I have negative 1 on the outside multiplied by the square root of negative x. What that does is it reflects or flips that graph across the x-axis. So instead of going up, I'm going to come and have the mirror image down below. This is minus the square root of x. So outside multiplied by a negative flips it over that x-axis. When we have a negative multiplied inside a function, it's going to be f of negative x. The graph reflects or flips over the y-axis. Once again, we have two functions to graph. The first is the parent function f of x equals the square root of x, starting at the origin. We're going to pop that in. And this is, once again, square root of x. Looking at g of x, notice that that negative is inside the square root. So I am going to reflect my graph across the y. So I still start at the origin, but I'm going to go left instead of right. It reflects off to the left. Quick and easy. Nothing's really complicated here. Just you have to remember which way things are moving. And as a reminder, you can use these note-taking guides on tests and quizzes. So let's go and recap and do our rules to remember. Our transformation rules are when a constant is added outside, that is the function f of x, and it's translated up. That goes in the direction you would think, c units. Then we have f of x minus c, and that is the same function, f of x, but it is translated down that many units. When we have a constant added on the inside, we have f of x, and normally we would think right when we're adding a positive, but remember when it's inside the function we go in the opposite direction, so that goes left h units. When we have f of x and we're subtracting h inside, that's the function f of x, and it is going right 8 units. H units, not 8 units. When the negative is multiplied on the outside, we have our function f of x, and it is reflected or flipped about the x-axis. When we have f of x and the negative is on the inside of the function, we have our function f of x, and it is reflected or flipped across the y-axis. I would box this set of rules in so they stand out for me when I'm on a test or a quiz. It's telling you exactly what to do each step of the way when you're graphing transformations in our family of functions unit. When we have a combination of transformations, first thing we have to do is identify the parent function and know the graph's general shape. Then, what way is it moving? What are those numbers telling me to do? And then lastly, graph and label those two functions. So looking at example 1, I've got a parent function of f of x equals x cubed. Knowing my parent functions and that this function x cubed does a little hitch, and that is my odd power function. So this is x cubed. That's my parent. Looking at g of x, first off, I've got plus 1 on the outside of the function. So plus 1 on the outside tells me up 1 from the origin. Next, I have minus 2 here on the inside of that function. Minus 2. Normally I would think I'd go left with that minus, but inside I remember it's the opposite direction, so I'm going to go right 2. So I look at my origin, I go up 1 for that plus 1 on the outside, and then to the right 1, 2, and this is my new origin. Then I just sketch in my graph. I basically bring my graph in, do my hitch, and then bring it down. Once you know where your origin is, you graph that, and you just decode your function to know where that is, up 1, right 2, and put your new origin in and sketch the graph. So this is x minus 2 cubed plus 1. Why don't you pause the video now and give example 2 a try. When you're ready, restart the video to check your answer. All right, let's see how you did. The first thing you should have noticed about the parent function is that it is a power and even, and its general shape is a parabola going through the vertex. So that is your parent function of x squared. Next, we have plus 3 inside. That tells me to move 3 left. And what other translation do we have in here? We have that negative outside, and that tells me to flip or reflect over the x-axis. Let me change pen colors here. Getting my starting point for my parabola, I'm going to move 3 to the left. I don't have to move up or down, but then I flip it. Instead of going up, I'm going to go down because it flips over that x-axis, and this is minus x plus 3 squared. Hope you did well with that. We have a couple more samples to try here on the guide, so let's go on and see if we can determine the equation from looking at the graph. There are a few simple steps to follow when you're given a graph and asked to write the function down. First, identify the family and the parent function. Looking at the graph below, that is an absolute value and my parent is f of x equals the absolute value of x. Next, identify how did that graph move? How was it translated? So if I look at this, I moved to the right 1, 2, 3. So I went right 3 and up 4. I didn't flip over or anything, so I don't need to do that. So now I need to write my general function. So what I do is I write f of x equals, and I put down the general notation with my variable. 3 right tells me, remember, left and right is inside the function and it's opposite of what you think. So minus 3 up 4 is going to be plus 4. So once you know the general rules, it's easy to write the equations. Go ahead and give example 4 a try. Okay, let's see how you did. First thing, what family does this belong to? It's even,